Hello, and welcome to the final stage of my Physics 2 key activity. For my research, I started searching for the meaning of a pendulum. A pendulum is a device that consists of a weight on a stick or thread that moves from side to side, and this example could be a clock. It is a body suspended from a support that makes it swing freely back and forth, all by gravity's influence. When it is displaced from its equilibrium position, a force due to gravity will accelerate back, starting to oscillate to the resting or equilibrium position. In this experiment, the main variable subjected to examination will be my dependent variable, time, my independent variable, amplitude, and my control variable, gravity. My hypothesis is the greater the distance from its equilibrium position when released, the more time it will take to complete 5 oscillations. And to test my hypothesis, I will be creating the most accurate homemade pendulum. My experiment will consist of modifying, increasing or decreasing the distance/amplitude, which is my independent variable, from its resting position and will until 5 oscillations. In conclusion, this experiment should help me approve or disapprove my hypothesis. Before doing my experiment, I continued researching for information of the pendulum and started to understand that the hypothesis that I originally offered was maybe incorrect, but that didn't stop me to continue my research/experiment. I wanted to test how does the amplitude affects the period of a pendulum. A period is the time it takes a pendulum to swing back to its original position, but in this case, the things that affected the period are the length of the thread, in this case, of a pendulum, and gravity, not amplitude. That means I was incorrect. That didn't stop me, and I wanted to test 2 experiments. Number 1, the amplitude. I tested a homemade pendulum, which I tied a thread of originally 50 centimeters to a ring and then pasted to a flat surface. Then amplitude. I modified in 4 different angles, 40 degrees, 50 degrees, 60 degrees, and 70 degrees to test my original hypothesis. And then time of a movement. I decided to measure the time in 5 oscillations. An oscillation is the time it takes the pendulum to do a whole cycle swinging from a point to another. For experiment number 2, I decided to test length instead of amplitude. So I used the same homemade pendulum, which I tied a thread of originally 50 centimeters to a ring and then pasted to a flat surface. I decided to test length, which I decrease and increase the length of the thread to 40 centimeters, 30 centimeters, and 20 centimeters, and test again my new hypothesis. And I also did the same time of the movement. I decided to measure it, the time, in 5 oscillations. Here you can see several pictures of a proof that I did my experimentation. But if you want to see it completely, you can use the YouTube link that it's next to the title, or you can scan the code for you to see the process completely. As you can see in my first experiment, the time of 5 oscillations didn't get affected by modifying the amplitude. This is due to restoring force. Restoring force is a force that pushes the mass back and towards its equilibrium position. And after doing my first experiment, I realized that my hypothesis was indeed incorrect. So I decided to search for the correct answer to my questions. So I did another experiment, as I mentioned it before, and here are the results of the new experiment. I started to do my research one more time, but in this case doing a variation in the length of the pendulum, the thread. Originally, my pendulum was 50 centimeters, so I decided to decrease the length, as I mentioned it before, to test my new hypothesis. In conclusion, after doing my 2 experiments, I realized that my first hypothesis was indeed incorrect with my first experiment. The greater the distance from its equilibrium position we release, the more time it will take to complete 5 oscillations. That was incorrect because the thing that affected the time was the length, not the amplitude. So my second hypothesis was indeed incorrect one. The greater the pendulum's length, the more time it will take to complete 5 oscillations. In conclusion, the longer the length of the pendulum, the longer it took to complete 5 oscillations, and the amplitude didn't affect in these experiments. That is why my hypothesis was incorrect, because I thought that the amplitude was the one that affected. Thank you.